In the last learning module and the videos that go along with that, I introduced the idea of corporate bonds and of how those bonds work, how the payments work, and how we can go about using the discounted cash flow method to find the value, which we then compare to price to make an investment decision. The idea being that if value is greater than price, we should invest. If value is equal to price, we should invest. But if the value is less than the price, then we should not invest. And at the same time we're comparing value and price, we're comparing expected return to required return. And for bonds, expected return had a special name, and that name is yield to maturity. If the expected return is greater than the required return, we should invest. If the two are equal, expected return is equal to required return, we should invest. But if the expected return is less than the required rate of return, we should not invest. Now, I know that bonds have a lot of moving parts and there's a lot of stuff going on, and I threw a lot at you in those videos from last time. So what I would like to do in this video, in this learning module, is just a review. Let's look at an example and see how all of this works. Let's make some changes, see how things change, and hopefully get a nice big picture look at bonds. And then we'll move on to preferred stock and common stock after that. Okay, so I'm going to share a document with you that has an example and some changes to it to demonstrate some other things. Okay, so what you see at the top of the page here is what we've seen before, and that is, first of all, a statement of the discounted cash flow method. And the discounted cash flow method is used to estimate value, right? Remember, we talked about last time that investments are going to have $2 amounts associated with them, basically. The price that the market provides to us and that we have to pay, we don't have any choice. And then the value. And the value is an individual assessment, what we believe this asset is worth. And then we compare the value, what we believe, to the market, what it costs. All right. And the way we estimate value, we're going to, in this class, estimate value is this thing called the discounted cash flow method. Remember from last time, the discounted cash flow method has 3 steps. All right, we have to know what all the expected future cash flows are. We have to know the investor's required rate of return. And then we put those 2 things together to find the present value. And that present value then is our estimate of value that we compare to price. Okay? Now, for now and for some time, the investor's required rate of return is something that I will give you. Later on, we'll learn how to estimate it. But for now, it's just going to be given. Right? Remember, though, our discussion of required rate of return having to do with interest and inflation and risk. All right, we'll come around to that later and see how to estimate it. But for now, that required rate of return is given. All right, so that I'll give you. Present value, we know how to calculate. The only thing we had to deal with the bonds was what are the expected future cash flows. All right, and we'll get back to that for a second. All right, as I said a second ago, the way we're going to make these investment decisions is by comparing value to price and at the same time comparing expected return to required return. they happen. There are two ways of saying the same thing. We're essentially making both comparisons at the same time. The thing to remember, as I said a few minutes ago, is that expected return for bonds is called yield to, maturity. Only bonds have a yield to maturity. Stocks don't, but they just have an expected return. Bonds, we call that expected return the yield to maturity. Okay, now we know how to do present value. I will give you the required return. All that's left is to figure out what are the expected future cash flows. And as we've talked about, every bond has these four characteristics: par value, coupon rate, payment schedule, and maturity date. And once you know those four characteristics, you know what to expect as far as cash flows. Okay? Once you know those four characteristics, par value, coupon rate, payment schedule, and maturity date, you know the expected future cash flows. Now, of course, we've talked about the fact that what you expect and what you get may be different. That's the basis of risk. And we talked about how default risk, or the bond being callable, or the bond being convertible, all of those things may cause the cash flows you get to be different from the cash flows you expected. But of course, here at the beginning, looking ahead at a bond, we don't know if those are going to happen, so we have to go with what we expect. All right. Pardon me, the par value is always paid at the maturity date. Right? In the meantime, depending upon the payment schedule, the coupon rates are paid. Right? The coupon payments could be annual, they could be quarterly, they could be semi-annually, they could be monthly. Pardon me. Generally, we're going to assume they're semi-annual because mostly they are with bonds. Right? So the payments will be made semi-annually. How much are the payments? Well, it depends upon the coupon rate, which is a percentage, of course, times the par value, and then divided to take into account the payment schedule. Right? Because remember, that coupon rate is always quoted per year. So if the payment is semi-annual, we need to divide by 2, or quarterly, we need to divide by 4, and so on and so on. And once we know that, all of that information, then we can let Excel do the calculation for us. Right? The value will be an equal present value calculation in Excel. Whoops. Right? The first payment, the first item is the rate, then the number of periods, then the payment, that's the coupon payment, and then the future value, that is the par value at maturity. So, and once you've done that, close the parentheses, hit enter, it will give you a dollar amount, and that dollar amount is the value, and it's the value that we compare to price. Okay? Then we take the next step and calculate the yield to maturity and compare that to the required return. Pardon me, and we'll get to that calculation in a second. So let's look at an example. Right? So let's imagine a corporate bond that has a par value of 1,000, a coupon rate of 6%, and remember, coupon rates are always quoted per year, a payment schedule of semi-annual, but now we have a little more information, semi-annual on June the 1st and December the 1st, and a maturity date on June the 1st of 2035. All right. So what do we know? Well, we know that the coupon payments are 6% times 1,000 or $60 divided by 2 because of the semi-annual or $30. So we have all of these coupon payments, $30. All right, that's just the coupon rate times the par value divided by 2 for whatever to account for the frequency of the payments, the payment schedule. All right, then of course, at the maturity date, you get both the par value and the coupon payment. Excuse me, those happen at the same time at the maturity date. Okay. And now the last question is, how many payments are there? How many periods remain? And that can be a little tricky. Right? If in this example, right, notice that we've got June and December payments. So we have to be careful. We also notice that the maturity is in June, not December. Okay, so in this year, 2024, the current year, there's one payment remaining, isn't there? December. June has already passed. December remains. Now, let me go back at the top. Notice, remember that our discounted cash flow method says all expected future cash flows. Past cash flows are not included, only future cash flows. So, pardon me, in the current year, the June 1st has already passed, already been paid. We're not including it. December 1st still remains. So in 2024, there's one payment. But in 2025, there are two. In 2026, there are two. And so on and so on and so on through 2034. There are two. But in 2035, the maturity year, there's only one, isn't there? Because in 2035, the payment happens on June the 1st, and then it's done, and there is no December payment. All right, so in 2024, there's one. In every other year, there are two, except 2035, when there's also only one. And that gives us a total of 22. All right? Be careful counting the payments. Remember that it's only future ones that we count, and be careful when the thing matures in that last year. So 22. All right, so given this bond, pardon me, here's our timeline. There are 22 semi-annual periods. Number of periods is 22. The amount of the coupon payment is 30 plus that 1,000 at maturity. All right, so let's find the value. Let's find the bond's value. Right, we know the par value is 1,000, the payment is 30, the number of periods is 22, and the rate is 2.25. Well, where in the world did I get that? Well, here is the required rate of return. I said I would give it to you. Don't worry about where it came from at this point. Here's the required rate of return, 4.5% per year, but our payments are semi-annual, are they not? Yes. So we need to divide it by 2, and that's why I've got 2.25%. Okay, put it into the Excel, equals PV. First is the rate. Here's 2.25% or 0.0225. Next is the number of periods, 22. Then the payment, and that refers to the coupon payment. And finally, the $1,000 future value. I close the parentheses, hit enter, and I get minus 1,129.03. And remember, excuse me, you can ignore that negative sign for now. That's just that quirk in Excel. When you put in positive numbers, it gives you back out negative numbers. Now let's think about that number a bit, 1129.03. That is the value, not the price. That is our individual estimate of value based on our required rate of return. It is not the price. Okay. Now, one thing to notice, one thing to make a point that I maybe didn't make before is that the rate that goes here, the rate that goes there is always the required return and never I'm sorry, I forgot the point I was trying to make. It's always the required return and never the coupon rate. Right? I know it's true because I've seen it for 29 years. The temptation is really, really strong to put the coupon rate here as the rate. Don't do that. What belongs here is the required rate of return and never the coupon rate. The coupon rate is used for one thing and one thing only, and that's figuring the amount of the coupon payment. And once you've figured the amount of the coupon payment, you will not use that coupon rate again. So what belongs here in the value calculation, what belongs here as rate is the required rate of return always, and the coupon rate never. Okay. All right. The other thing to notice is that notice that our value, 1129.03, is greater than that $1,000 par value. Well, if you think about it, this bond is paying us 6%, right? There's the coupon rate, 6%. This bond is paying us 6%. But we only require 4.5%. Let me say that again. Our requirement is 4.5%, but this bond is paying us 6%. It's paying us more than we require. That makes the bond more valuable and pushes the value up. Now we're talking value and not price. But because this bond is paying us 6%, which is more than we require, the value is greater than par. And that's maybe worth, noting here. If the coupon rate, let me go higher. That's a little hard to see, sorry. If the coupon rate is greater than the required return, then value is greater than par. And that's what we see here. The coupon rate is 6%. The required return is only 4.5%. So the coupon is greater than required return. It's paying us more than we require. So the value is greater than par, greater than that $1,000, and that will always be true. Okay, now let's take the next step. Let's take the next step and calculate the bond's yield to maturity or expected return that we can compare to the required return. Okay, now yield to maturity or expected return is a percentage, so we're going to use the rate function. And you see it there, equals rate. All right, and the arguments equals rate are number of periods, payment, the coupon payment, present value with a negative sign, and future value. All right, you can see it's almost the same as finding the value. Right, the things in that those parentheses are almost the same. But in this case, we're calculating a percentage. All right, so equals rate, number of periods, that's 22. You could look back at the timeline. The coupon payments are 30. The current price of the bond, let me scroll back up. Right here. Here's the statement. The current price, let the current market price be 115.5% of par value. Now, remember last time when we looked at that actual listing online, we saw that bond prices are not quoted in dollars, they're quoted in percentage of par value. So this is what you would see if you look the bond up, 115.5% of par value. And that is where this 1155 comes from. That's simply 115.5% of the $1,000 par. Right? And that's where that 1155 came from. All right. Put all that in the parentheses, close the parentheses, hit enter, and you get 2.11, and it's a percentage. But it is the semi-annual percentage. And I don't want things left in semi-annual or quarterly or monthly terms. We need to change that, adjust it to make it annual. And to turn semi-annual into annual, we multiply by 2. And that's what I did here. I multiplied by 2. 2.11 times 2, 4.22%. And that is the annual yield to maturity. Okay. All right. Now, a couple of things. First of all, when we're calculating yield to maturity, what goes here as present value is always price and never value. When we're calculating yield to maturity, what goes there as present value is always the price, that percentage of par value, and never the value you just calculate. Okay? All right? So, should we invest in this bond? Well, let's see. The value is less than the price, right? Because the value was 1129.03, and that's less than that price of 1155. So we do not invest. At the same time, the expected return or yield to maturity is less than the required return. Right, our expected return, that's the yield to maturity, that was 4.22%. And that's less than the required return of 4.50%. So we do not invest. Okay. All right. So So what we've done here is taken these four characteristics, used them to build a timeline. I gave you the required return and you used it to find value. 1129.03 value. Then we compared that value to the price. Okay. Now we took it one step further. I gave you the price, 115.50%. We plugged in that price and calculated yield to maturity or expected return, two ways of saying the same thing. We then compared that expected return to the required return. Expected return is less than we require, so we do not invest. One thing to point out here, those two comparisons will always give you the same answer. They will not contradict each other because they're two ways of saying the same thing. Right? Comparing value to price, comparing expected return to required return is really two ways of saying the same thing, and they will always give you the same decision. All right. And I've added a couple things here that we need to be really, really careful here. When you're finding the value, the rate that you use is always the required return and never the coupon rate. If you put the coupon rate, you're always going to get 1,000 no matter what. So what goes there is the required return and never the coupon rate. And when you're calculating yield to maturity, what goes here is present value is always the price and never the value. Right. One more thing before we move on. Notice that the price of the bond is more than 100%, 115.5%. When we turn that into dollars, that's 1,155. Is that right? Or I'm getting it? Yeah, $1,155 more than the $1,000 par value. This is an example of a bond selling at a premium. And premium simply means price is greater than 100%. Whoops. 100% of par value. That's all that means when the bond is selling at a premium. Doesn't mean it's a good deal. It doesn't mean it's a bad bond. It doesn't mean anything more than the price is higher than par value. The price is more than 100%. Okay, so let's take another example. Same bond. All four characteristics are the same. The coupon rate, the par value, the payment schedule, the number of payments, the maturity date, all of that's the same. But now I want to change to 8% required rate of return. In the first example, our required rate of return was 4.5%. Now let's do this again with a required return of 8%. Okay? Right. So the only thing that changes is that our rate, instead of being 2.25%, is now 4. 8% for the full year, divide by 2 because of the semi-annual. All right. Remember that this is always the required return and never the coupon rate. So our required return is 8%, divided by 2 for the semi-annual. I get 4, plug everything in, right? First is the rate, 0.04. Then the number of periods, 22. Payment, 30. Future value, 1,000. Close the parentheses, hit enter. I get 855.49. What is that 855.49? Well, it is the value of this bond, not the price, the value of this bond to an investor with an 8% per year required rate of return. That's what it is. What are we going to do with it? Well, we're going to compare it to price in order to make an investment decision. Right? Value and price are not the same thing. They're what we're going to compare. Now, in the first example, our value was greater than that $1,000 par, wasn't it? In this example, the value is less than that $1,000 par, and that is because of the required return. Okay. If the required return is greater than the coupon, oh dear, greater than the coupon, then value is less than par. Think about it. How much is this bond paying us? Well, it's paying us 6%. That's the coupon rate, right? But how much do we require? Well, we require more than that, 8%. So this bond is not paying us as much as we require. That makes it less valuable and pushes the value, I almost said price, pushes the value below par. In this case, the 8% required return is greater than our 6% coupon. That pushes the value 855.49 below par. All right. If the required is less than the coupon, then the value is greater than par. If the required is greater than coupon, then the value is less than par. Okay. All right. Let's leave the market price the same. We've changed the required return. We'll leave the market price the same. And notice when I do the yield to maturity calculation, it stays the same. So let's see. I changed the required rate of return and value changed. I left the price the same and yield to maturity stayed the same. All right. So what does that tell us? That tells us that value is based on the required rate of return, but yield to maturity or expected return, that is based on the price. Every time the required rate of return changes, the value changes because that's an individual thing. But as long as the price stays the same, the yield to maturity or expected return stays the same because that's based on price. Okay. Right. In this case, right, in this example, the price is 115.5% of par, still selling at a premium because the price is greater than 100%. And one more example. In this example, same bond, same coupon rate, same payment schedule, same maturity, same par value. Only now let's change the required rate of return to 6%. Right? First, we did it with 4.5% required return. Then we did it with 8% required return. Now let's do it with 6% required return. And notice that that required return is the same as the coupon rate in this example. Okay, everything is the same except for that rate. Right? Required return is 6% a year. We divide it by 2 because of the semi-annual and get 3%. Right? So I do the value calculation equals present value. The rate is 3%. Coupon rate, wait, I said that backwards. 3% required return, not coupon rate. Sorry. Next is the number of periods, 22. The payment is 30. The future value is 1,000. Do the calculation, and I find the value is $1,000, exactly equal to par. And that's because in this example, our required rate of return and our coupon rate are equal. First example, required return was less than coupon, and that made the value greater than par. Second example, required return was greater than coupon. That made the value less than par. Third example, required return and coupon are equal. The value is equal to par. All right, that's probably worth saying, huh? If required return is equal to the coupon rate, then value is equal to par. Okay, and as always, we take the next step, keep the price unchanged. We'll leave it alone and calculate the yield to maturity. And as long as I don't change the price, the yield to maturity stays the same. All right, so there are some more examples of finding the value with maybe a little more insight into what happens as the required return changes, that sort of what's at a premium. Now, I said if the price is greater than 100%, it's a premium. If the price is less than 100%, then it's a discount. And it doesn't mean it's cheap. It doesn't mean it's a bad bond. It just means that it's selling for a price less than par. Okay, now up to this point, I haven't changed the price, so we haven't changed the yield to maturity. Let's see what happens when that market price changes. Well, what happens is the higher market price means a lower yield to maturity, and a lower market price means a higher yield to maturity. Now, remember when we started, we had our market price at $11.55, a premium, and our yield to maturity was 4.22%. Now let's try it again. Market price of 92.75%, par value of $927.50. Where did I get $927.50? Well, that's 92.75% of the $1,000 par. 92.75% of 1,000 is $927.50. In this example, the price is less than the par value. So this is at a discount. And what happens to the yield to maturity? It increases. Right? The future value is 1,000. That's the par. Excuse me. Payment is 30. That's the coupon payment. Number of periods, 22. And the present value is that price, $927.50. And remember that this is always price and never, oh gosh, and never value. Right? Put all those in, equals rate, number of periods, payment, present value, future value. I get 3.48%, which is of course semi-annual. I got to multiply it by 2 to get annual. That's 6.96% per year. The price went down to 92.75%, but the yield to, and as a result, the yield to maturity went up, right? It's now above that 6% required rate of, or coupon rate, sorry. Okay. At 11.55, a premium, our yield to maturity was 4.22%. Now at 92.75%, a discount, our yield to maturity is 6.96%. Price and yield to maturity have an inverse relationship. As the price goes up, the yield goes down. As the price goes down, the yield goes up. And that makes sense if you think about the bond. The bond is a set series of cash flows. In this case, 22 payments of $30 plus $1,000 at the end. And as the price changes, those stay the same. So changes in price amount to paying more or less for that set series of payments, right? And it just makes sense that the more you pay, the less your return will be. Yeah, the dollar amounts are the same, but you had to pay more to get them. If the price goes down, your return is higher. Same series of payments, but you got them for less. All right. You may have heard, you may have noticed if you watch the financial news at all, that when the Federal Reserve says they're going to raise interest rates, the bond market falls. The Fed announces they're going to raise interest rates, bond prices fall. On the other hand, if the Fed says they're going to lower interest rates, then bond prices go up. It's this relationship that they're talking about. Okay, and finally, what if the market price is 100% of par value, or in this case, exactly that $1,000 par? In other words, it's selling at par. What is the yield to maturity? Well, let's see. We put 1,000 here, right? This is always price and never value. So the price is 1,000. Put it into our calculation, and I get 3% multiplied by 2. That gives me 6%. Right? Because the price and the par value are exactly the same. In this case, that yield to maturity equals the coupon rate. All right. One other thing, and then I'll stop pressing on it. Notice that when you do the yield to maturity, you've got to make the present value negative, else you'll get an error message. There has to be a negative and a positive in there, or Excel will give you an error message, right? Just for the sake of consistency, make the present value negative. Okay, like I said when we began, the bonds are a lot. I've thrown a lot at you. Happily, as we move on, things get a little less complicated. The reason I started with bonds, even though they can be complicated, is because it's so straightforward finding out the expected future cash flows. With preferred stock and common stock, it's not quite so straightforward. So that's why we started at bonds. Okay, as always, if you have questions, if you need assistance, be sure and let me know. Don't hesitate. I'll do my best to help. Thanks.